It's an honor for me to introduce the speakers. So usually you don't introduce yourself first, but in that sense, my name is Marvin. I'm a global sales and account manager at OpenTAS. And with me today, we have Nasir from OpenTAS as portfolio innovation manager. And what's really great is that we are not alone today as OpenTAS. We also invited HyBird. So welcome, Sascha and Ben. Nice to see you in the webinar. Hello.
Nice to see you, Marvin. Thank you.
Hi. And Sascha is the VP Solutions of the Oil and Gas of HyBird, and Ben Laws is the Solution Consultant. So nice to have you all in the meeting, and let's hope for a good session in the next minutes. And let me introduce, and let's directly jump into the topic. Let me introduce the webinar today in showing the vision of the autonomous terminal. The autonomous terminal is a future vision we defined together with our partners and customers, where terminal management, operations, and decision-making are driven by advanced technology. And in the end, it's a journey, and the journey towards this vision requires a step-by-step approach. And this journey is already in progress. So some terminals are quite ahead, some terminals are just starting, but important in my opinion is that we start together this journey. And really crucial for that is the interaction between the terminal and the partner ecosystem. And we see ourselves together with HyBird as part of this partner ecosystem. And also this partner ecosystem must be digitalized and automated. And integration with partners, clients, vendors, external systems is essential anyhow to create that, let's say, fully connected, responsive terminal environment. And today we are showing, let's say, one extract of that autonomous terminal. So we cannot show the complete picture because it's really interlinked and quite complex. But today we show how HyBird and OpenTAS can really create value together. And in the end, it's about, we will demonstrate with use cases how terminal management from OpenTAS, the digital twin solution of HyBird, can be integrated and can really create value, especially for operations, terminal management, but also for maintenance. And this integration is one of the mentioned steps towards the autonomous terminal, or how we call it in the webinar, terminal of tomorrow. So that's as a kind of introduction. And with that, let's say we are going more and more into the contents, and I give the word to Nasir.
Thank you, Marvin, for this beautiful introduction. I hope I have control now.
You have
Yes, okay. Perfect. Yes. Before we dive into terminals and digital twins, let me start with something much simpler. You know, my wife used to send me a grocery list with no particular order. So I would just go into the supermarket, grab something from one corner and then from the other corner, and then back and forth. And I wasted a lot of time and asked the staff where things were and left slightly frustrated. But a couple of years ago, she changed something very simple. She just started structuring the list according to the actual route through the supermarket. So now I move very efficiently, no back and forth, no friction. And in the end, happy wife, happy life. And now getting to our business into this context, in the oil and gas industry, terminals operate in highly regulated and asset-intensive environments where safety, uptime, and coordination are non-negotiable. And the thing is, most terminals have already systems. Most terminals have already data, but often the data is not structured along the operational route, as I told you. Planning happens in one place, maintenance in another place, and reporting somewhere else. So teams walk back and forth. And the challenge is no longer digitization, it is orchestration. Like you can see here the connected dots. It is structure, because autonomy does not start with only AI. So only AI is not enough, but it starts with structured data and connected workflows. And that is exactly what I want to show you today. I will show you today 3 demos from real use cases. First of all, the resource conflict prevention. So you can see here two schedules that are planned. First of all, we can see here the pump A, which is scheduled for maintenance, and down underneath, you can see the diesel transfer, and they collide. And the system here shows, if you click on the second scheduling, you will see the conflict happening. And the system is giving us a suggestion to assign other asset on the pump B. So this is the solution which comes based on structured data, based on workflows that are connected. So this is not a full operational planning engine, but it demonstrates something critical. Conflicts can be detected before execution. Planning becomes coordinated instead of reactive. This is the first step toward autonomy. Let me show you the next use case. So we see here something very typical in terminal operations. Email comes in, and in this example, you're seeing that the email contains a vessel notification. MT Pacific Glory is arriving at the Rotterdam Botlek terminal, and the product it carries is Super Clean 95 with a quantity of 14,000 cubic meters. And in tank 12A, it is contained. In many terminals, this is where fragmentation begins. Yeah, an email arrives, someone forwards it, another person copies the data into a system, another person schedules activities. And suddenly you have three versions of truth. But in our example, this email is processed through a module that is called @ANP, which is, by the way, also available in the Microsoft Marketplace, or you can see it on our website, OpenTAS.com. Instead of manually transferring information, the structured content is extracted and transformed into a structured operational request. This request is then posted into Microsoft Teams for approval. Let me show you how this is in action. You can see here, directly after the email has been received, it has been started, the workflow has been started in the background, and it creates a notification and a chat entry in which the extracted data is processed. And there you can see all the important informations, which then can be approved. So we'll see here in this demo that the approval is happening through a comment. So you can comment on this approval element, or you can also reject it. But in this example, we will approve it, and the success notification is received. And after this approval has happened, it goes direct to execution. A work order is created on our OpenTAS system. So this is the whole use case, which you can see, and also you can jump in directly into the work order detail page and see and connect the dots, connect the work order to the assigned services. On our OpenTAS system, where we have seen the pump A and the pump B. Earlier, pump B handled additional load because pump A was under maintenance. Now we can see a follow-up inspection. Let me demonstrate it. So when clicking on this icon, a notification comes up to create a follow-up inspection. After the follow-up inspection, you are directly forwarded to the work order detail page. And in this detail page, you see the assets, the asset checklists. And the operator can see, okay, this is the inspection I have to make. And the checklist has then been connected to the work order. So now you see the whole loop we saw before is closed now. The technician sees the context, the planner sees the history, the organization retains knowledge, and this is how governance becomes embedded into a workflow. Everything you have seen so far lives in a structured operational data. And you remember my supermarket story from the beginning. The interesting part of this little story is nothing about the supermarket has changed. Only the structure of the information changed, and suddenly the experience became efficient. Now imagine having data and all of this modernization and then putting another dimension on top of that. This is where things become interesting. So I invite Sascha and Ben from HyBird to show us when data becomes spatially visible, when teams see the use cases in its real physical context to make decisions directly on hand. Sascha, over to you.
Nasir, thank you. And Marvin, thank you for having us with you guys today. Really appreciate it. And I want to pick it up. I want to zoom out a little bit out of the process and back into something that Nasir actually said, which is several times, which is that data is extremely important, right? Your AI workflows are only going to be as robust as the data that you have in your systems. And we've had the opportunity to travel, see customers, industrial sites across the verticals, from building materials to nuclear, all the way down to the terminal operators, the topic which we're discussing today. And one thing has become quite obvious for us, right? Every single conversation we have with the terminal manager or their team, it's really about how do we embed AI in the future to drive process safety, to drive efficiency in our operations and maintenance processes, also for HSEQ. And there's two obstacles that stand in the way to actually make that work. Number one is that we typically see that any industrial facility, including the terminal operators out there, are basically dealing with three different versions of asset reality, how we call them. Number one is the physical assets in the field. Number two is the asset data that usually resides in a CMMS system or EAM system, the SAPs and IFSs, etc. And the last reality, which sometimes may be a little bit disacknowledged, is the engineering drawings and P&IDs. And what we typically see that those realities don't really align. But in the future, you want to run, co-pilot functions on top of your asset data. So we typically say start with the asset foundation itself. And a digital twin deployment or a digital twin study is exactly the right vehicle to do so, because we are generating a true up of these three realities, unifying it against the 3D model of the terminal. And from there, we are integrating it operationally into the backend processes and everything that happens inside the terminal as well. And that's really the key differentiation. You will have heard the word digital twin, I presume, in many different contexts, from engineering to process industries. We are really talking about a digital twin that delivers value for maintenance and for operations in the day-to-day. And today, we don't want to walk you through a lot of slides. We want to actually make this quite tangible and show you what that really looks like in reality. And for that, I'm inviting Ben to walk you through what it really looks like. Ben, over to you.
Great. Thank you, Sascha. And good afternoon indeed. Good morning to everybody down the line. So as Sascha has just kind of introduced, the use of a digital twin can really support, indeed enhance the use cases that Nasir has just presented, but also a lot more besides and on top of that as well. But before we get to those use cases, we need to address the big challenge, which is those data silos that Sascha just walked through, bringing those under a single umbrella, a single source of truth. That's really the foundation we need to establish in any digital twin that's going to achieve anything beneficial for the day-to-day maintenance and operations of a facility. So how do we do that with our system? Now, HyBird delivers a platform called Clarity. And Clarity, which I'll introduce and then demonstrate in a live demo shortly, firstly serves to provide a really robust foundation for all of that information that is in many cases quite separate, quite disparate across a facility, across different teams, different software packages. We aim to bring that together under a single roof. It's the same three data sources that Sascha has just described. We have the reality, that as built on the ground asset that of course is modified over time, but really stands to represent exactly what is built and what is running on a daily basis. That's that top layer you see in the diagram on the left-hand side. We then have the asset register data, which is equipment details, component details, often stored in the EAM system. But it also represents information that comes continuously from the facility, condition monitoring information, SCADA information, performance data, etc. Equally important. And then the documents, schematics, procedures, manuals, etc. Each of those three often exist separately. With Clarity, we can bring them under a single platform. We can integrate them together to provide a really good structure for applying certain capabilities and certain use cases. So that's always our first step when deploying our platform. It also, as you'll see towards the end of the webinar, sets an excellent foundation for that autonomous future that many of our customers, many operators around the world are looking to achieve, not in 30 or 35 years, but really in 5-10 years timeline. So before I go any further, let me just introduce what the basics of Clarity is. Clarity offers the industrial operating system for heavy industrial assets, tank terminals, other oil and gas facilities in other sectors as well. We work across the process industries in different ways. Now, Clarity, first and foremost, deploys that digital twin. In our definition, that is combining the different data sources to really provide a single source of understanding and truth about the asset that we're concerned with, that asset that is running day to day, achieving its purposes. Of course, we want to do that as safely, efficiently, and reliably as possible. Now, on top of that digital twin, we build a number of modular capabilities. Now, those capabilities span the whole range of daily maintenance and operation tasks. We have a CMMS toolkit that I'll showcase a little bit of. We have health and safety workflows built in, like e-permitting, lockout, tagout procedures, isolation procedures, etc. We also have full document management system, things for supporting CapEx project planning as well. Of course, having a understanding of what is built on the ground is really useful if you can use that to support engineering activities remotely or without bringing in contractors, minimizing travel, etc. And then we have other focuses on asset performance, monitoring and management of the daily operation. We deploy as a web platform and as a mobile app, as you'll see in a few minutes. And many of our customers are using the whole range of use cases. Some are using more focused use cases. I'll showcase just a snapshot today, and there's a lot more we can get into. But that foundation, which I want to emphasize again, is that digital twin, making sure you have a connected foundation, connected sources of information that are up to date, that can be updated, of course, as things change on the ground or in the data, and you can put to work with trust and with certainty. But before I jump to that live demo, I just want to talk a little bit about one of the questions we get most frequently in our engagements with operators, which is, how do we take this concept and put it into application? How do we develop that digital twin, put it to work? Now, the first step is, in most cases, developing that picture of the as-built reality. Now, that's a process that we conduct as a project that requires scanning of the facility, both using ground-based equipment and, in some cases, aerial drone footage as well. So that's a scanning activity that we conduct either ourselves or with our partners to really build up high-fidelity, photorealistic image, a 3D image of what is built on that facility within its boundaries. Then we're bringing in all of the rest of the data, the documents, the information on schematic, process and instrumentation diagrams, the asset register. That's a big connection and integration process. Once that's done, we're happy, and we've worked in collaboration with our customers. We're looking at connecting systems, workflows, use cases, really bringing that digital twin into the stage where it can add value, improve efficiency, improve reliability of the day-to-day lives of the teams we work with, which are often maintenance teams, but also end users, operators, people in charge of the running and performance of the facility. That process obviously takes some time to onboard and deliver value. That's a collaborative process. It's not something that's done instantly, but crucially, it's much more efficient than you might expect to build firstly the digital twin and then put it to good use. So I'll stop with the slide just for a moment now. I'm going to share my screen with our web-based platform. So just bear with me 1 second. Just going to activate that. So what you should see on the screen now is Clarity Web. As I say, we have a mobile platform I'll show a short video of momentarily. But first, I want to walk you through what the digital twin is and a couple of use cases. So as you see here, we have a scan of an oil and gas tank terminal facility, in this case, in the United States. Now, this is data. This is the result of that scanning process I just described, where we've gathered information primarily from ground-based scanning of the entire asset, where we have the jetty on the left-hand side, all the way through to the terminals and the storage tanks. Now, I can navigate this using our mouse and keyboard. I'm going to move quite slowly. This is a smooth process for me on my local machine, streaming the data from the cloud that we manage, although the Teams broadcast is often a little delayed, so I'll keep it nice and slow for our demo purposes. But as we move in, we can start to see the detail of this asset. But not only can we see the detail, we can see these little tags everywhere. Now, these tags, in this case, represent individual pieces of equipment. You can start to see some details appear on the right-hand side. Now, as I move in towards this pump pad, I'll explain what details we're showing. So in this case, I've just got about 80, 85 tags on this model. These are all synthetic, so we're not representing customer data here for obvious reasons. But what we can see is exactly where these pieces of equipment are located, what the name is, and then if I click this table button, we can actually view the information in the asset register directly from Clarity. Again, this is all synthetic, so it's not related to any one customer or representative of any one naming convention, but we can see pieces of information about pumps, about safety systems, about motors, about storage tanks, whatever the type may be. And I can access that information, or I can simply click on the tag in the 3D model, and I can see information that directly comes from my EAM system or whatever system has been integrated. Indeed, the master data may be stored in Clarity. It all depends on what the customer needs. So I have access to this instantly. I don't need to route around the EAM. I know exactly what information is available, but crucially, I know where that sits in 3D space, because every equipment is assigned a point, a coordinate within the system, within the model that is universally accessible, and I can then provide information for within my asset data. I can see links to related equipment, such as this pump is linked to the pump motor, as you'd expect. And then I can see documents that are also linked to this piece of equipment. Smart P&IDs, preventive maintenance, workflows, procedures, manuals. All of this is stored either in the Clarity document management system or in an external document management system. So that's that fair data source that is seamlessly brought together within Clarity. But it doesn't stop there. If I move things around a little bit, we can also look at the work activity. So not only can I instantly locate all of my information within the spatial context, I can see all of the maintenance activities that are going on this piece of equipment. In this case, we've got 2 work orders that are relevant, and we've got some observations that have been made in recent weeks and months. If I jump onto this work order, it's going to open up a new tab in this case. I can now see all of my work orders that are on this example facility. Maybe this is filtered from the past 3 months or 6 months, or it's from a certain team. We can really manage the information as needed, and we can see different statuses. Some are in draft, some are raised, some are completed. Now, these work orders are exactly the type of information that can come from the OpenTAS system. We can raise, as Nasir showed in his second use case, a work order directly. Now, that can be integrated into Clarity, so we can display that same work order on the same piece of equipment within 3D context. So here, I loaded up this Tank 103 Pump B base plate work order. Click of a button, and I can see exactly where that's related to. We're back in the same location as before. I can see what is around it. So I've got some other equipment linked to it. I can navigate with my mouse and keyboard once again. I can see there's other pieces such as this transmitter calibration. I've got internal inspection on this nearby tank. I can see the work that is going to happen. I can see who's being assigned, the member of the team, the equipment and the location. Again, lots of this information is coming from the integrated platform like the OpenTAS system. What we can also do here is run a safety analysis. A safety analysis for looking at things like concurrent work activities or work that's going on in the same space or relevant isolation points. That oftentimes will take quite a long time. It will require you to talk to different teams. It will require you to look in different software packages. It will require you to look at different documents. Not only is that inconvenient and time consuming, it's actually not fully accurate. It's easy to make mistakes when you're handling disparate data. But with the Clarity Safety Analysis tool, with a click of a button, I can see all of my linked conflicts to this given work order. I can see I've got a schedule overlap, given this is from last week, as we can see it started, for a particular seal replacement. It's conflicting with the same equipment. If there's any permits or LOTO procedures in place, I can look at those. And I can observe any recent observations. I can see there's none in the past 7 days. Let's look at 21 days, 3 weeks, for example, or can look at even for February, 25 days. And I can see there are a number of observations to be made about this tank, this pump, I should say. Now, where are these observations coming from? Some of them could be reported from Clarity using our mobile app, which I'll show in a second. Some could be reported in the OpenTAS system. Some could come from a separate system entirely that we're working with. It's not only about dominating the reporting method, it's about bringing information together and making sure operators, maintenance technicians have a really coherent, reliable picture of the facility and the activities going on. The same applies for proximity analysis. We can see what's going on within, in this case, we've got, 20 meters. We can see the work orders, any observations, it's all at our fingertips. We don't need to hunt for this information. And crucially, we can trust it.
And Ben, one question. So which seems
Go ahead,
like,
Marvin.
from an operator's point of view, you are showing the chat here, or let's say it's a truck loading bay, which means you can also illustrate planned activities, for example, or already executed.
Exactly. Great point. So this is a maintenance use case, as you can appreciate. I'll just jump back to my other tab here. So we're looking in the same, we've now gone to equipment mode. And let's have a look at, you mentioned jetties, you mentioned truck loading bays. Let's use our navigation just to jump up. And let's navigate over to a particular truck loading bay. So we can see over here, we've got a section of truck loading. And we can move along. And here we could tag, just as before, equipment. So we have loading arms, we have meters. Again, all synthetic for the purposes of this demo. But within this system, we have a route from the spatial context into all sorts of information. We could do, once again, maintenance, but like you say, we could link in operational procedures as well. Fill in events, what has been filled, when was it filled, how much was taken away, what the upcoming activities are as well. It doesn't just need to be work orders. We can look at that operation reality. Again, that's provided from a system provided by OpenTAS or another system entirely. We can integrate it all together and display a coherent view for operations and maintenance. So I'll leave it there. There's a lot more we can talk about using this 3D model that you see here. Things like measurements is a great application, zoning to define areas for isolation, for hot work, for example, safety studies, we can go into more detail. But I just want to finish up with a quick video. Perhaps I will ask Marvin to reshare the PowerPoint slides. If you can do that, Marvin, that'd be great. Fantastic. So I just want to talk about let's take control, the mobile use case. Now, this ties very nicely into that observation reporting workflow, or what Nasir talked about, the checklist workflow as well. So if we want to complete activities on site in the field, it's pretty inconvenient to have to rely on a web-based platform exclusively. And that's why we have Clarity Mobile. Clarity Mobile allows you to take exactly the same information and the digital twin directly into the field with you on a suitable mobile device, tablet, iPhone, etc. Not only can you take that information in, you can use the power of augmented reality to really understand what information is relevant to the place you are standing in at that very moment. So let's just play this video. It's just 60 seconds long. It's going to show the same model, as you see, the same pump pad, only this time we're going into the field with a mobile device. We've zoomed in, and now we're going to see the operator on site with his mobile device approaching a nearby pump to the one we were studying. And what he's looking to do is understand the relevant asset information in that point. So this is the phone screen, that same footage now from the perspective of the phone, and we can see overlaid tags that are localized using augmented reality. This is not a QR code based technology or a tag based technology. This is purely from augmented reality. The system knows where he is, knows what equipment is relevant, and then once you've accessed the equipment, you can access everything else I talked about. The documents, in this case, a P&ID. We can access the work orders. We could access the operational details, as Marvin just asked about. Everything is once again at your fingertips, both the information, but also the workflows. If you want to complete inspection checklists with the help of augmented reality, if you want to report a defect or an observation without having to take that back into the office, you can use the mobile application directly in field to make that a much smoother process than it would be otherwise. So that's just a 15-minute or so snippet of clarity. Hopefully that gives you a good impression. But we want to finish, and I'll pass back to Sascha to talk about the future, that autonomous future that we're all aiming for, both to enable and ultimately to achieve. So Sascha, over to you.
Yeah, and thank you very much. Really clear and impressive. Marvin said in the beginning, this is about terminal autonomy and the path to terminal autonomy. So I hope what Ben has been able to show you on the HyBird side specifically, and also Nasir on his side, is that there's not it's not only a vision, right? You can already execute a lot of these use cases today, straight away. Especially when we look at the digital twin, the operators start working with spatial context instead of just working in table structures. Essentially, we have the power of smart P&IDs bringing together what is basically, you remember these three asset realities, what is on paper being connected entirely to the asset register. So I really know what I'm working on, which has a huge implication for process safety in a terminal. And finally, the ability to cross-collaborate. Many of you will have contractors on site on a regular basis that need to localize equipment, execute work orders, all of this because the system is open to bring your contractors in and manage through the permission management system what the contractor is able to see and work on. You can bring them on board flawlessly, so as any other employee that joins the team, basically, which I think is very important in a time where there's a lot of turnover in the workforce. One workforce generation is retiring, another one is coming on board. And for that specific reason, it makes sense to manage tacit knowledge. Now, we also understand that this is a journey. Not every customer will immediately jump on a digital twin, automate all the processes and plug in robotic systems, even though that exists already. And we see more and more customers start using robotics for first inspection use cases, such as SWOT, etc., which we've done before. But it's a journey. And what we typically do is we sit down with you, we understand where are you in this journey exactly, and how can we take you from one level to the next. Very conscious that there's two extremes, the pen and paper operations, and let's say the robotic autonomy, right? And the truth lies somewhere in the middle. But the message here is really that we sit down with you and we try to understand how can we move you jointly from one point to the next. And I think OpenTAS and HyBird are bringing a lot of capabilities together here to make that happen. And I guess that would be the main question from the audience. How do we actually make that happen? So Marvin, what do you think?
Yeah, let me take over the screen again. And in the end, how I see it, like if you're going on a journey in private life, it usually costs money. And in my opinion, it's really important in business life and to go into the autonomous terminal digitalization area that we create business cases together. So which means like not only implementing technology because it's fancy, it's nice, it's really to create value. And for that, in my opinion, it's really important that we work together with terminal operators, with our customers, to really show and demonstrate that the vision we have and what we're already doing partly is really adding value. And that's an open invitation from us as HyBird and from OpenTAS to really think together in this use case. So first of all, it's important that we are at Stock Expo. It's already in 2 weeks, so 10 and 11 of March, where you can meet us. We will also have a joint partner presentation on the Tuesday. And really important, which I would like to emphasize, is that we would like to have on-site workshops with 2 dedicated customers. So please contact us today, the next week, or at Stock Expo afterwards, that we together, so you as a terminal operator, HyBird and OpenTAS, think together what are, let's say, actionable value-adding use cases. Without a high investment, we go into the workshops, we think about how can we, let's say, bundle the terminal operation knowledge with the technology we have to really create value and to really influence the industry. And that's what I always emphasize. Technology is one side, but it's in the end also the people which have to connect to really make it happen. So you can have the best technology, but I'm quite confident with HyBird, OpenTAS, and with you as potential, let's say, pilot in that area, that we can really succeed and influence something positive. So that's anyhow a wrap up and a kind of action from my side. And with that, let me check if we already have some questions from the audience. Let me open. So we have some actually. Let me read through it and then I will assign it to us as speakers. So let me take the first question. What do you see terminal operators do wrong when dealing with new technologies, and what is your advice? I think this might be something for Nasir.
Yeah, this is that's a very important question, because this question arises, I think, very common. And what I often personally see is not a lack of investment in technology, it's quite the opposite. So many terminal operators introduce new tools, dashboards, or analytic solutions, but the underlying workflows remain fragmented. And this is the crucial thing. The technology gets added on top of operational complexity instead of simplifying it. So another common issue is starting with the solution instead of the problem. There is excitement about AI, digital twins, automation. So all these, I would say, buzzwords, but less clarity about the specific operational pain point. And this should have been solved first. So my advice would be start with the execution. Define 2 or 3 concrete operational use cases. This you can do with us together. That create measurable impact. Ensure that responsibilities and data ownership are clearly defined. And then scale intelligence on top of that foundation. Because autonomy is not something you buy. It emerges from disciplined, structured operations. I hope that answers the question.
Hopefully. For me, it's clear, Nasir. Thank you so much. Maybe that's one for Sascha. Many companies position digital twins primarily as visualization tools. Where do you see the real operational impact beyond visualization in terminal environments?
Yeah, that's a good one, Marvin. I think it comes a bit back to what I said in the beginning, right? There's different understandings or different terminologies and understandings for digital twins out there. Now, what hopefully became clear a little bit today is that a digital twin lives off the value that you feed it with in terms of data. In other words, a lot of companies run table structures, asset registers, lists, but there's no spatial context whatsoever. So what a digital twin really does is, for instance, allows you to design your health and safety workflows with spatial context and link it back into equipment. It allows you, as Ben showed, to avoid work conflict, which is proven in the terminal industry to be a main cause of, let's say, safety hazards in the field. This overlapping or conflicting work, right? Where you can use the spatial context then to proactively inform the operator that, there's an area that we should not be working on. And last but not least, it's also the ability to integrate checklists and your workflows and procedures in the terminal and link it conditionally as well. So that, for instance, in the case of a terminal operator, your permitting process is linked to the LOTO process, for instance, that the permit only gets issued when the LOTO process has been executed. and things like that, but entirely integrated into the digital twin. So you can really select from the 3D model what you're working on, and you can be sure that these equipments have been correctly selected. That's really just a couple of examples of where the power of the digital twin really kicks in. It's basically also allowing customers to realize the value that they've already, or realize the investments they've already put into an EAM or CMMS system, right? And a lot of the data is not being used correctly. So we try to make use of that value layer, let's say, and extract even more value out of it, I would say.
Thanks, Sascha. Next one, and I think that's the last one. You work with many terminal operators across the globe. What are the main challenges you see in terms of bringing value derived from having an intelligent TMS? So if it's okay, I will take that one. And globally, to be honest, there are quite some different challenges. So let's take one main challenges of Europe. And I think where everybody is aware of, is like a lot of people are going into retirement, and less than people want to work in the oil and gas industry, and we're losing a lot of knowledge, right? It's a demography anyhow taking place. Let's take especially Germany and Middle Europe in general. And we are losing a lot of knowledge when it comes to how to assign rules, for example, when it comes to customs knowledge, how to manage in general operations. And for sure, it's a big benefit of having an intelligent TMS to have, let's say, methodologies and rules to get the knowledge from the, let's say, experienced staff into business rules and bringing that into a software, right? Because usually in some companies, you have maybe 2 to 5 people knowing all the operations. And if they leave, you have a big issue as a terminal operator. And with an intelligent GMS, you can grab that knowledge and bring it to business rules, like Nasir was also showing in the beginning. It's about how to maintain the processes. And that's a big, big benefit of having an intelligent TMS in place, especially in Europe with us old people everywhere. Good. With that, I think there are no further questions. I think we are close to close the meeting. And I would say thank you, first of all, to the audience, but also to you, to us as speakers. And I hope to see you at Stock Expo, and to stay in touch and to have hopefully the workshops in the next weeks. Looking forward to that. Thank you all and have a good afternoon or good morning. Thank you so much.
Thanks, everyone. Thank you, Marvin and team.